the purpose of this video is going to be, we want to carry out the chain rule using this sequence of steps here, this algorithm. So in this problem, find dw dt if, so w is a function of x, y, and z, and x, y, and z are all functions of t. So the picture is going to be w depends on x, y, and z, and x, y, and z all depend on t. So what is our formula going to be? dw dt is going to be, so we compute all of the necessary partial derivatives, or just normal derivatives, partial w, partial t, partial x, partial w, partial y, partial w, partial z, dx dt, dy dt, dz dt, okay, like this. So dw dt is going to be, so there's three ways to get from the top to the bottom. 1, 2, 3. So partial derivative w respect x times dx dt plus the partial derivative of w with respect to y times dy dt. So first I did that path, then I did that path, and then the partial derivative of w with respect to z times dz dt. And you'll note that this formula is just like this one here, except that there is one more term tacked on. Now that we have a third intermediate variable, we have a third term going on here. Okay, so what are all of the derivatives here? The partial derivative of w with respect to x is going to be y. dx dt is going to be negative sine t. The partial derivative of w with respect to y will be x. The derivative of y with respect to t will be cosine t. The partial derivative of w with respect to z is 1. The derivative of z with respect to t is going to be 1. Now, you might think that we're all done. We plopped in all the partial derivatives, but in general, we always want to write, in our final answers, we want to get rid of the intermediate variables. We want to get rid of y and x there, because those are intermediate variables, and write everything in terms of the independent variables, in this case just t. So y is sine t, so sine t times negative sine t, plus x is cosine t times cosine t plus 1, so cosine squared t minus sine squared t plus 1. So it's actually just like the example at the end of the last video, except that we have an extra plus z here with that z is equal to t. Okay, so this is 3 intermediate variables, 1 independent variable. Okay, what else can we do? Okay, so now we need to find the partial derivative of w with respect to r, and the partial derivative of w with respect to with respect to s, if w depends on x and y both depend on r and s. So for this one, here's the chart. We need to compute partial w, partial x, partial w, partial y, partial x, partial r, partial x, partial s, partial y, partial r, partial y, partial s. So we need to compute these 6 partial derivatives. Okay, let's list out those partial derivatives really quick here. So partial w, partial x is going to be 2x. Partial w, partial y is going to be 2y. And let's go ahead and already replace x and y in terms of the independent variables r and s. So this is 2 times r minus s. This is 2 times r plus s. Then we need partial x, partial r. Derivative to this with respect to r is 1. Partial x, partial s. Derivative to this with respect to s is -1. Partial y, partial r is 1. Partial y, partial s is also 1. Okay, so now at the point, if we want partial w, partial r, how many ways are there to go from w to r? We can go 2 ways. We can go w to x to r, or we can go w to y to r. So the first way to get there has partial w, partial x. Partial w, partial s is 2 times r minus s times partial x, partial r times 1. The other way to get there, partial w, partial y, is 2 times r plus s times partial y, partial r times 1. So there's 2 ways to go from w to r. One way gives you partial w, partial x times partial x, partial r. This times this. The second way gives you partial w, partial y times partial y, partial r. This times this. And then similarly, partial w, partial s. There are 2 ways to go from w to s, w to x to s, w to y to s. So the first way, w to x, partial w, partial x is 2 times r minus s. Partial x, partial s must be, it will be -1 here. Then partial w, partial y is 2 times r plus s times partial y, partial s, and that is 1 here. And so I'm sure those terms down there simplify, but we'll say that this is our final answer.